Welcome everyone. Welcome to this online course on Introduction to Lie algebras. I am Venkatesh, working as an associate professor in Indian Institute of Science, Bangalore. So, in this video, I will briefly explain you what we will be learning in this course. So, first we begin with some background about the course. So, what we are interested in, let us see. So, a Norwegian mathematician, Sophus Lie, discovered the continuous transformation groups in the 1870s. So, they are now called Lie groups after him. So, the Lie groups could be better understood by linearizing them and studying the corresponding generating vector fields. So, they are called infinitesimal generators. So, these generators are subject to a linearized version of the group law. So, now called commutator bracket and have the structure of what is today we call Lie algebras. These days both Lie groups and Lie algebras, they have become essential to many parts of mathematics and theoretical physics. But in the meantime, Lie algebras have become a central object of interest on their own right due to their various applications. For example, their applications vary from number theory to all the way to mathematical physics. So, this course aimed to give a very basic algebraic introduction to finite dimensional Lie algebras. So, we expect that the audience to have a good knowledge in linear algebra and basic algebra. The course will focus only on finite dimensional Lie algebras over complex numbers. So, we will not work with any other field or rings. So, we always assume all the vector spaces that you encounter in this course, they are defined over complex numbers. We will begin with the basic definitions and properties of finite dimensional Lie algebras and prove some fundamental results about nilpotent and solvable Lie algebras. So, then we will prove the Cartan's criteria for solvability and semi-simplicity. We will also move on to the structure theory of semi-simple Lie algebras and prove their root space decomposition. Finally, we will give Dinkin's classification of irreducible finite root systems and outline how this helps us to the classification of finite dimensional semi-simple Lie algebras over complex numbers. So, in this course we end with the classification of finite dimensional semi-simple Lie algebras. So, we will strictly follow the following references, especially the first book by Erdmann and Wilden will be very strictly followed in this course. So, this book title is Introduction to Lie algebras. So, this is available Indian edition, I believe. So, another book, very famous book on this subject is James C. Humphrey's Introduction to Lie algebras and representation theory, and one more fantastic book on the subject is Carter's book on Lie algebras of finite and affine type. So, both these books I would recommend for the graduate level students. So, for example, you can actually read these two books, Humphreys and Carter books as second reading books. Okay. First, I would suggest you better start with Erdmann and Wilden. So, in this course, as I said, we will only focus on the structure theory part and we do the classification of finite dimensional semi-simple Lie algebra. So, I will be offering a follow-up course on the representation theory. In that course, I will actually develop a finite dimensional representation theory of finite dimensional semi-simple Lie algebras. I hope all of you enjoy this course and benefit from this course. Thank you very much.